pretty much a 3-day section. Partially because I didn't want to just overfill you with new information every day. So yesterday we were focused on just the U substitution portion. And I tried to have you guys go to the homework and set up U substitution if you could. Now you probably ran into some that didn't really seem like it fit U substitution, and it shouldn't, because we're not doing U substitution on every problem. So part of the reason I mentioned this is a 3-day section. Today we're going to go over how to integrate with the U substitution and the little details that we didn't even get to yet. Tomorrow I'll go over the other methods, which is long division, technically completing the square. I feel like there was one more. Was natural log in this section? I think it was the next one. I think natural log is next section, but it might be this one. I don't know. So integrating with substitution isn't going to be every problem. It basically just makes some problems a lot easier. It traditionally ties in the best with power rule for integration, because a lot of the power rule questions are kind of set up where they just fit that nicely. So it's not going to work for all of them. What you'll probably find is the ones that it works the least well on are rationals, like a fraction. And we'll get to why that is and all that kind of stuff. But so I believe on this page you guys have the U substitution filled out but not integrated. Okay? Because my fifth hour we ended up integrating some of these because they were getting confused on how the substitution worked. So we just went ahead and integrated. And I don't know if that was the same for you or not. Oops. Here, let's zoom in a little bit. Let's go to B, because I feel like B, this is where my other class got confused just because the way trig was set up, right? If I remember correctly, I don't even remember who came up to do this one, but it took us a handful of tries to figure out the U substitution part, right? Like I think the first guess was to let U equal cosine 4x, which sort of seems right. Like it makes sense, but it doesn't work because the U the derivative of it isn't there. So we ended up figuring out that the U substitution was just 4x. And then the derivative of U prime or du, however you want to write it, you're absolutely allowed to write x prime over here too, by the way. dx is like proper notation, but they're the same thing. So this was 4 dx. Although now that I do that looks weird writing 1 prime, 1 dx. Whatever. The actual substitution itself, this is where some are getting thrown off. Wherever a 4x is written, we're going to put a u in place of it. So like right here, where I have a 4x, I'm essentially going to scribble out 4x and put a u. And the next step is where they were thrown off, which I get. Wherever there's a 4 times a dx, we're going to replace that with du or u prime. They don't have to be next to each other, right? Like 4 and dx are separate things just being multiplied. And if you look in the problem, the 4 is multiplied in the front, the dx is multiplied at the end. It's okay that they're separated. If you want to rearrange this problem before you do it, you can. Like if it just makes it easier for you, you could move the 4 to right here. But otherwise, we are going to take the 4 times the dx and replace that with du. And so then we're going to integrate cosine of u du. feel like I was supposed to call on somebody first, but I don't remember why. Was it James? How come? Why was I supposed to call on James first? Okay, James. Didn't you go at the end of the hour, though? I feel like you did, but that's all right. You could like let yourself shine here. You can be the star of the hour. How do we integrate cosine of u, du? Wait a sec. Oh dear. Whether it's positive or negative? Okay, good. That's perfect. That's good. It is positive sine, yes. So derivative of cosine is negative sine. So the integral of cosine is positive sine. Okay, so we've got sine of u plus c. Okay. James, is there anybody you want to get retribution on, even though Aiden is not here? Oh, okay.
Plug in the 4x with u, so we sine 4x plus c.
Excellent job. So once you integrate with the u symbols, then you can substitute back the original information. If it makes it easier for some of you, you're welcome to put it in parentheses, like if it makes it easier to identify the angle. How are we feeling on that? Like, is there part of something up there that maybe it was confusing why I wrote it or anything? I don't know.
Just the DU kind of just disappeared on.
Yes. Now, I get to ask that one every single year because it's kind of weird. I get it. This is my best explanation. When we're doing derivatives, like if we do the derivative of u cubed, the answer is 3u squared du. So it's kind of like that du just kind of appeared out of thin air as well. So when we do integrating, it's reversed. It disappears. Yeah. You need the du to be able to integrate. And then once you integrate, it will no longer be part of the problem.
Wait, so we don't need to solve for C?
You can't unless they give you numbers.
Okay.
Yeah, most of the time you won't be solving for C.
Yeah.
And it's usually semi-obvious when you do because they'll have to give you some sort of specific information about the integrated equation to be able to. Yeah. Later on, what's going to happen is they'll ask you for a particular solution, which is when you figure out C. A general solution is when you have C, but they haven't started using those terms yet. Okay, should we do a couple more of these? Are you guys feeling pretty good about the actual integration? Should I phrase that better? Should I have you guys vote somehow?
Yes, we need democracy. Second most for a college.
I mean, it's not wrong, but it still isn't a democracy. I'm just trying to take your opinion. But you guys have zero opinion. Yes. E, sure. Did you pick the worst one of all?
Yeah.
Oh, nice. All right. Okay. Any particular thing about E that looked terrible to you?
The fact that it's on the bottom.
Oh, okay. He's correct. Now, you can't always just bring it to the top. In this case, we can. Once we do our substitution, then it hopefully will be a little bit more obvious, but not until we actually substitute. Where am I? 8x dx. Now, this was one of the problems where we were... Actually, you know what? I never even showed you the other method of substitution. I just had you guys write in an 8 yesterday, correct? Okay. I do know that some students don't, like that doesn't click with them. It just doesn't seem to make sense to them to just put in a number. So there is another method we can do. In the problem, we only have an x dx. And so what you can do is you can solve this equation for x dx. And you would divide both sides by 8. So du divided by 8, or 1/8 du, would be x dx. And so instead of just putting in the correct number, you can do this method, where the actual substitution, in place of x dx, I'm going to write 1/8 du. And that absolutely will work. If that doesn't make sense to you, that's fine. But I'm going to put 1/8 du on the top. On the bottom, I've got u to the 6th. The 1/8 is a multiplier, and so a lot of people will just put that out front rather than deal with it. Like they'll ignore it until the end of the problem. Now this says du over u6, and then absolutely correct, you can just move it to the top if you would like and write it as a negative power. And then that way it's traditionally a lot easier to see that you'll just be using the power rule. Now, if this method I showed you doesn't make sense, because some people just see things one way. If this method I showed you doesn't make sense, then just write in the 8 and the 1/8 out front, and you still get the same thing. It's the exact same answer when you're done. So you kind of have two different methods you can pick from. Integrating this, well, we'd have 1/8 still, and then the integral of u to the negative 6 would be u to the negative 5 divided by negative 5 plus c. Yeah, definitely. On the next line, I'll write it as negative 1/40. And then instead of u, we can put back the original information, which was 4x squared plus 3. Now, the question I got yesterday, which I hadn't even thought about, this actually probably wouldn't be the multiple choice answer you see, because they still do that same thing where they don't like negative powers in final answers for some reason. I mean, to me, it makes no sense, but whatever. Like, I feel like if you're smart enough to be able to do all this, you're smart enough to understand negative powers. But they usually change it to a positive power. So this would, final answer on a multiple choice would probably be negative 1 over 40 4x squared plus 3 to the positive 5th plus c at the end. Absolutely, I am good with this on a test answer, though. Like free response, you don't have to change it to however you want. That help with number or letter E? Okay. I'm going to guess the part that just was hard to see was bring it up top as a negative 6. Yeah. Okay, then I want to go to the next part, which I think you'll be totally good with. It's just something you wouldn't have thought about probably. The next page, oh, okay, wait, I'll do this one quick and then go on to the part I'm talking about. I am most definitely not doing this entire page because to me it's a waste of time. Like these are just going to be ones you memorize later anyway. So this is just to show you how they actually integrate 10. No, you can't do this yet. We didn't learn natural log. I'm pretty sure natural log's in the next section. I don't know why this would be here. Did I miss natural log or something? It's not on the previous pages, is it?
I think it's on like the sheet at like the start.
At the very bottom?
Yeah.
Yeah, it is on there. But the next section is where we go over, the rest of the trig ones, natural log, ease, like the bottom of that sheet. I'm trying to think if I'm missing something, but, I mean, you do this with natural log, so I don't know why it's, we'll skip this page for now.
They might be wanting to break up the sine of the cosine.
That's how you do it with natural log.
Could you not do that with?
It's U substitution with natural log. Yeah, I mean, that's, I'll save it for the next section because I'll do it with natural log. I usually do that as an example with natural log parts. I mean, I'm guessing it's just in there to get you exposed to natural log ahead of time. I don't know. Let's do A. That was my fault. I remember seeing that in notes, and I guess I just never put it together in my head that we hadn't done it yet. Zach, you were called on last, I think. Okay, who's going to help me with this one? Obi, how is this problem different than the ones we've done mainly? For substitution. Yeah, this one's a definite integral. It's got the upper and lower bounds. Now, in terms of integrating, no difference. First thing we figure out is what would be the u for substitution, because if this is going to work with u substitution, we need to have something and its derivative present. And accidentally, for the most part, a lot of people will kind of look at secant to be the u because it's got a power squared. That's not what's different. No, that's part's not different. I'll show you. But I'm hoping that you catch on to the fact that secant squared is the derivative of tangent. Okay, so u is tangent. You know, that wouldn't happen if you didn't eat your lunch. Okay, when we put this in the problem, Obi, do you want to do this part? Do you want to pass it on to somebody else? Okay. Person, number, whatever. No, not here. Not here, I don't think. I think that's your sweatshirt, right? Yeah. Okay, I'm on. How do I put this information in?
So you have to find u squared now because the d of u is secant squared.
Wait, say it again?
Like the integral of u squared.
Are you trying to give me an answer or like how to put it in?
Like the next step.
Okay, so I would want to, wherever there was a tangent of x, put in u. Wherever there's secant squared dx, put in du. Like, that's kind of what we wrote down for what I wrote down for substitution. That's why I wasn't sure if you were trying to give me an answer for like final or were you seeing this squared and thinking it somehow was affecting u? Got you. No, the u that we decided was just tangent, and so this problem would be written as the integral of u du. Okay? this would be marked wrong on the AP test. And it's definitely a technicality. Oh, let me rephrase that. This would be marked wrong on the free response part of the AP test. They don't look at any of your work on the multiple choice. And the reason this would be marked wrong, the technicality, is once you do use substitution, you're basically stating that you switched the variable to u. But you didn't switch everything into a u value. So these numbers that get written on the integral symbol are x values, right? Like x equals 0, x equals pi fourths. And so if I write the integral symbol with the x values in place of the numbers, but I write u values in the equation, they consider that incorrect because you've got a mixture of information. And again, this is only on free response. I don't care what you do on multiple choice. Most people are, rightly so, lazy and just do scratch work on multiple choice. And so you would never take the time to switch these. Okay? So oh, go ahead.
So they'd mark it wrong if you like put that as the answer, or like if they saw that?
If they saw you write that. Yeah, that's annoying. Okay, so here's what you have to do. We wrote down that u is tangent of whatever the x is. So if we want to find the correct values, so at x equals 0, the u value would be tangent of 0, which is 0. So in place of x equals 0, I would write u equals 0, which I guess for this one we were half correct. Okay, now at x equals pi fourths, the u value would be tangent of pi fourths. Tangent of pi fourths, I believe, is 1. Yeah. So instead of me writing pi fourths, I would have to write u equals 1. And then that would be considered correct. It's a lot of details. Like, this isn't to say that you don't know how to do the problem, don't know how to get an answer, but if what you're writing is incorrect, they'll mark that incorrect. Okay, so now from here, now we can integrate. So u to the first, if I integrate it, would be u to the second over 2, and we don't write plus c because we've got numbers. 0 to 1. If you want to write plus c, go for it. Okay? We don't actually have to switch back to x values because we figured out the corresponding numbers to u values. We actually could just leave it and finish the problem with 1 and 0. So this would be 1/2 minus 0, or 1/2. Now, definite integral problems are where you start to decide if it's worth it to write u substitution or not. Remember how I said yesterday some people like to do this substitution in their head? If you do the substitution in your head, you can keep using 0 and pi fourths and not ever have to change it. Because if you were the person that decided that you knew this was tangent to the first times its derivative, you could immediately write the answer as tangent squared x over 2 from 0 to pi fourths. And now when I plug this information in, tangent of pi fourths is 1, 1 squared is 1, divided by 2 is 1/2. Tangent of 0, 0 squared is 0, divided by 2 is 0. And you would get the same answer. So if you're a person that does the substitution, you would have to write everything in black, which is not bad. It's not wrong. It's just clearly slower. If you're a person that likes to do information in your head and it makes sense to you, well, then it's quite often time valuable not to do substitution. It's always going to be your choice. But I'm just trying to show you how come some people don't like you doing use substitution. How come some people do. It's just... Okay, Emily, what were you trying to ask? For the blue? Because if I did the blue, I never even did use substitution. I went straight to the blue line. Because if I'm looking at this problem, like I've done substitution enough that I would look at this and I would recognize that secant squared is the derivative of tangent. And so I would know that this is trying to say tangent to the first. And so I would know the answer immediately is tangent to the second divided by 2. And then I wouldn't have to do any type of substitution at all. But some people like to stay organized and they get messed up if they don't. And so some people absolutely will do substitution all the time. And that's what's written in black.
So you don't do that for the u, you don't substitute u down there for tangent x because you're already.
I didn't do substitution. Because I knew how to do it without it.
Yeah, I mean like for the black, the u put it in like we did the other.
Oh, you mean I didn't change it back to x's?
Yeah.
I didn't need to because I actually changed the numbers into u's.
If you did, then you'd get.
Yeah, if you changed it back to x's, you'd get what's written in blue. So you can. It's not wrong. You can change it back to x's if you want. These problems aren't harder, but it adds a whole nother level of detail that you probably wouldn't have thought about ahead of, otherwise. Okay, should we try another one of these together? This was all the farther I wanted to go today, was showing you how to use definite integrals with substitution. Okay, so it looks like we have another trig one. Okay.
Would it still work if you did the method that we used beforehand where you just plug in the hypothesis into the x and then you subtract 20 and 0?
That's what I did right here in blue.
Right.
So yes. It feels like they are different problems, but they're the same, just switching back between u and the x information. Okay, I don't remember who we're on. Oh, I'm on, yes. Who's going to help me next? Jake.
I'm not sure that's me.
Jacob?
Oh, yeah.
Oh.
Um,
I mean, that was a good attempt, though. Yeah. I haven't asked anything yet, though. You sound like you're terrified to answer this one. Okay. Wait, no, yesterday you were here, I think, right? What, yesterday was the day you were gone? Are you totally lost as to what we're doing?
a little bit.
Then I feel like we can pick somebody else. Yep. Yeah, it's pretty crucial to know substitution to be able to do this, yeah. Who do you want to help you then?
15.
Oh, you were picking again. Oh, I was trying to let Jacob pick. 15, Laura. All I was trying to have the first person do was pick the substitution stuff.
I'll be honest, I'm not sure which it would
Okay. Oh, are you trying to decide which direction?
be. Like which would be you?
Oh, good. No, that's perfect. Sometimes it actually won't matter. Like there will be questions we get where it can be either one. And so what you're trying to think to yourself is absolutely valid. Like the one thing that's different on this problem that actually forces which one to be you is the squared. Or no, cubed. Sorry, cubed. Because our goal is to use power rule, the cubed is what we want to focus on, and that item is what we'd want to make u. So that'll be kind of the deciding factor sometimes. So I'm going to say let u equal cosine of 2 theta. Now, on this time, I didn't write just 2 theta. How come I picked the whole cosine thing? Or actually, I should say, how come Laura picked the whole cosine thing? It wouldn't work, actually, because the cubed is on the cosine. So the derivative of sine is not cosine cubed. So you're correct. It can be either way. But the one with the power is actually what we're going to integrate because we're going to use the power rule on that cubed. Not always, most of the time. I mean, it can be set up weird where it's not. You just have to start recognizing it once you do more of them. But I chose the whole cosine equation because I recognize that sine is written in the problem. The last time we did one of these, we just made the u substitution the angle. And that's because the only other information in the problem was a single number. So cosine was used because I see sine up there. Now, the issue is this isn't perfect. Like the derivative of cosine 2 theta is negative 2 sine 2 theta d theta. Are we okay with that 2 came from? Probably. Should be, but I can remind you if you're not. It's from chain rule of doing the derivative of an angle. So this negative 2 is clearly what's not the same. I prefer the method where you just write in the correct number. But if you prefer that method I showed you a little bit ago where you solve for this and divide by negative 2, you can. Like some people, it just clicks both ways. I prefer writing the number incorrect and then balancing it out front. And I partially like to do that method because I usually don't use substitution when I integrate. I'm the type of person that gets lost in a problem because I do a lot of it in my head, and I'll get lost if I have to write everything down. Now, obviously, over the years, I've been able to get both methods down pretty good because I teach it, so I have to, right? But when I was a student, I was not good at doing use substitution because it was hard for me to write it and keep things clear in my head. Okay, now, if I substitute, I'm going to have the integral. I'm going to put the negative 1/2 up front. The numerator is going to become du. The denominator is going to become u cubed. One tip I will tell you, du can never be in the denominator. And so if you're sometimes confused about which, like this one, if you weren't sure which one was supposed to be u and which one du, I couldn't make sine u because that would make du kind of in the denominator, and it can't be. So this one, oh wait, I'll put that below. I'm going to rewrite as u negative 3 du. And then the last step, I didn't switch the numbers yet, so I have to switch those. Laura, is there somebody you want to choose to have switch the numbers for us?
Row 3, person 4.
Lou.
So then you just plug in cosine for the u.
Good. So we'll do 0 first, I guess. And so then it would be cosine of 2 times 0, which is 1. Correct. Nice. And so then we would have cosine of 2 times pi over 6, which would be pi thirds. I'm going to draw that once. Wait. I'm mainly drawing it so people figure out where it comes from. Because I know we have quite a few people that get stuck on this step still. Like after grading tests all year, I know a bunch of you are stuck on this step. So pi thirds is going to be a 60-degree angle. I drew my triangle terrible, which means this is a 30. The ratio on a 30 to 60 triangle is 1 to 2 to square root of 3. I know some of you use that weird finger trick. I know some of you memorize the unit circle. You can pick whichever way you like. This is what I've always resorted to, is just drawing it. Cosine would be 1 over 2. Okay, I wrote E. That looks like a W. There we go. So I've got negative 1/2 integral. Actually, I don't know why I'm rewriting this. I already have it written above. I just didn't write the numbers on it. From 1 to 1/2. And absolutely this can screw you up because these numbers, when you're switching them to U values, aren't necessarily going to be correct. Like, it started off with smaller to larger, and now once we replaced them, it is not. And that's okay. It's still going to be the correct answer. So I've got negative 1/2 times u to the negative 2 divided by negative 2 from 1 to 1/2. And instead of simplifying, I'm just going to plug in stuff and go. Negative 1/4 times 1/2 to the negative 2 power is like 2 over 1 squared. One more time? Yeah, if I were smart enough to see both negative signs, yes. You guys are getting much better at catching me on the little things right away. So 1/2 to the negative 2 is the same as 2 over 1 squared, which would be 4. Minus the positive 1/4 still. Now I'm going to do 1 to the negative 2 power, which is 1. So I have 1 minus 1/4, which is 3/4. And what you will find is it's shocking how much longer these problems become just with little things. Like the U substitution adds a layer of longerness. And then once you're going to have a definite integral, that absolutely adds more things to it. We are going to get to the problem at some point, or get to the point here where some of our problems are like half a page. It's kind of annoying. But it doesn't mean they're more difficult, they're just more steps. Okay, I'm going to stop there because I don't want to use up all your time. I would like you guys to have a little bit of time in here to try some of the problems. Basically, I would probably stick to the first page or two of your homework because near the end of your homework is going to be different methods. And you haven't seen those methods yet, so that's fine. So I would stick to the first page or two.